In this video, we're going to discuss multiplicity, end behavior, and sketching graphs of polynomials. So the first thing I did was grab this graphic from the textbook, and it's really self-explanatory, right? Well, let's look at exactly what this means. The graphic basically describes end behaviors based on the n, which is the exponent on our leading term, and whether or not a is positive or negative. So basically, we're looking to see if it's going to be reflected over the x-axis or not. So let's look at some simple examples first. So here is first a graph of x squared. And we know that to be a simple parabola. And I know that no matter what I add to the other side, if I add 3x, if I subtract 4, whatever it happens to be, that I'm still going to have an upward facing parabola. Or in other words, it's on the left side, it's going upwards, and on the right side, it's going upwards. So when we have an even exponent on our lead coefficient, our lead term, then it's going to be going upwards. Well, what if I change it to, let's say, a 6? And if I zoom out, it's still going to be going upwards from on the right side and the left side. So no matter what I do, as long as the lead term or the largest coefficient is even, it's going to be going upwards on either side. So if you remember the shape of a parabola, and I can change this to be whatever it was, I can change this to be another coefficient of even, I can change it to be a coefficient of odd, no matter what, but either way, from the right and from the left, it's going upward. So looking at that graphic from the book, this is what it's talking about when we're pointing at it right here. So that's what we're talking about here. When I have an even n, it's going to be going upwards to the left and upwards to the right on both sides, and it doesn't matter how big my lead term is. So let's look over at Desmos one more time. And when we talk about the lead term, I'm talking about the value, the largest exponent. So let's say I change that to 12. It's still going upwards. Well, I'll change that to an odd number. Well, what I'm talking about, usually when we place polynomials in the correct order, we do it in descending degree, meaning that the x to the 12 should have been first. So no matter what, it is going to be going up to the left and up to the right. So if you can memorize the shape of a parabola, then any other even degreed polynomial will be the exact same. So let's look at x cubed, or r odd. If you'll notice, it goes down on the left and it goes up on the right. And that still applies no matter what I do to the second or the third term. So x squared, I can go plus 6, I can plus 6x, minus 7. Either way, I know it has that weird kind of bend, but either way, it still goes down on the left and up on the right. And I can change the polynomial, but no matter what, as long as the lead coefficient or the largest degree, I said lead term, excuse me, is odd, it's still going to change it to that final polynomial. Now, if you notice, when I took it back to the first, all of a sudden it went up. Well, if you notice, now technically my lead or my largest degree is 2, so that's now an even polynomial. But putting it back into an odd, we see that it goes from left downwards and right upwards. So looking back at our notes, this is the situation it's talking about here, where again, the end behavior is going to go down to the left and up to the right. So what we're looking at now is the second row of what happens when a is less than 0. In other words, when there's a negative in front of the polynomial. Well, hopefully by now we know that when there's a negative in front of any polynomial, it reflects over the x-axis. So what we've done is we've changed the direction. So what was on our even polynomial, what normally went up, now goes down in both directions. And our odd polynomial, what went down, now goes up, and what was up now goes down. So let's look at what that looks like on Desmos. So if you notice, I've got the x squared turned on, and all I'm going to do in front of it now is put a negative. So of course that's going to reflect it over the x-axis. And now it's going down to the left and down to the right. Same thing here. If I took this polynomial, now right now it's an even polynomial because of the largest degree, so let me change that. Let me change that. I'll change it to a 4. So now it's doing exactly what we thought. It's going down to the left and up to the right. But if I put a negative in front of it, it's going to reflect it over the x-axis. And now it's going to be going going up to the left and down to the right. So that's the thing you have to do first, is memorize that box, that graphic. Now let's talk about multiplicity. And here's the definition of multiplicity and x-intercepts taken from the book. So if I want to look at this one, this polynomial is in vertex form, and we know that this transformation inside the parentheses means it goes to the right 4, and this one on the outside means it goes down 4. So I know that my vertex is going to be at the point 4, -4. But what I want to do is I want to find the roots. So what I have to do is I have to put this in expanded form. Remember, the roots, the zeros, the x-intercepts, they all mean exactly the same thing. So from this, I can't read the zeros from this. I have to have it completely factored. I could do the quadratic form, but what we're going to do is we're going to stick to things that are in factored form. So let's expand this thing out. And we get to this polynomial. Now again, I could use the quadratic formula, but again, I'm going to go to factored form. So I know that when I when I factor this one, I've got x minus 6 and x minus 2. So when we try to find the zeros of a polynomial, we set that equal to 0. So this is x minus 6 is equal to 0, or one of the roots is going to be 6. This is x minus 2 is equal to 0. So one of the roots is going to be 2. And looking at our graph, we're going to find that this is exactly the situation that we have here. My vertex is here at -4, 4, and then I have a root at 2 and a root at 6, or a 0 at 2 and 6. But let's talk about the multiplicity of this. So if we notice that it crosses the graph at 2 and it crosses the graph at 6. And this is exactly what we would expect based on the fact that these both have a multiplicity of 1. Well, what on earth am I talking about? Well, when I'm looking at a polynomial in completely factored form, this root, or this binomial, has a degree of 1. It's x minus 6 to the first. This is x minus 2 to the first. So what it's saying in this theorem here is that R has if every binomial has an odd multiplicity, then the graph is going to cross the x-axis. And that's what it did. It crossed the x-axis at 6, and it crossed the x-axis at 2. And it says if it has a 0, the 0 has an even multiplicity, then it's going to touch the x-axis. So let's look at what I'm talking about. Let's see if I have another function. Let's do this. We have f of x is equal to, and we're going to do this completely factored out. And we're going to get to even how to factor these later in another section. But let's say if I had x minus 3, and I had a factor of x plus 1, and I also had a factor of x minus 4. And what I want to do is I want to change this one to be a multiplicity of 2. So this one has 1, this one has 1, and this one has 2. So this is just an example. I've just taken a polynomial and I've made it up. But in fully factored form, this is going to be x minus 3, x plus 1, and x minus 4. So according to this theory, that because this one has an odd multiplicity, this should cross. Because this one has an even multiplicity, it should touch. And this one has an odd multiplicity, it should cross. So let's put it into Desmos and see what happens. So here's our graph, and what I'm going to do is I'm going to zoom out a little bit just to show you again what happens. It's going off to the left, and it's going up to the right. But let's zoom in a little bit and find out what happens here. We said that the multiplicity determines whether it touches the graph or whether it passes through. Well, let's look at this. On this particular part here, this is x minus 3 to the first. So remember, if it's the binomial is x minus 3, that the root is the opposite, or a positive 3, which is right here. And again, that has a multiplicity of 1, or an odd multiplicity, so it goes through. The second one, this is x plus 1, so this means that the root is now at -1, and because it's an even multiplicity, it touches and goes up. And then the last one is x minus 4. And so what it's going to do is it's going to go through at 4, but it's an odd multiplicity, so it passes through. The other thing to look at is the end behavior, and this is consistent. Like, well, I don't see an x, an even, an odd, or whatever, but if I count the complete number of degrees, so there's a 1 at here at the x minus 3, there's 2 more after the x plus 1, and then x minus 4, so I have a total degree of 4, and so that's even, and it's going to go upwards. So let's look at another example. So first of all, let's look at this polynomial. Here's another example. And first of all, let's determine the degree. So when I'm looking at that, I have a degree of 1 here, I have 3, and then I have 4. So this has a total degree of 8. So that again is an even polynomial. There's no negative in front of an even degreed polynomial. There's no negative in front, so it's going to go off to the left and it's going to go up to the right. So that's, first of all, that's going to be our end behavior. But now let's look at our multiplicity. So first of all, I want you to think about it and figure out the roots. Figure out the roots and then figure out what it should do at each of these roots. So again, the roots end up to be the opposite of this. So there's a root at -2. This is odd, so it's going to cross. This one is, we're going to take the opposite of this, so this is going to be a multiplicity of 1. Excuse me, it's going to be a root of 1 with a multiplicity of 3. That's odd, so it's going to cross. And then this is going to be a root of 5. This is even, so it's going to touch. So let's go over to Desmos and see if that actually is the case. So here's the graph, and I zoomed it way out so you could see that again, it's going to be going up to the left and it's going to be going up to the right. But let's zoom in now on these roots. And we said that at the root of -2, which is right here, it's going to pass through because again, it's an odd multiplicity. When we have the root here at 1, it's going to pass through because it's got an odd multiplicity. And we have the graph of the root at 5, it's going to touch, not go through, and that's an even multiplicity. So what we're going to do is we're going to go over to a worksheet and practice this as well. So here's some examples. So the first thing we want to do is we want to identify the zeros or the x-intercepts. So that is going to be here at, let's see if I can draw. This is going to be here at x equals 5. This one is going to be at -2, and this one is going to be at a -5. And then this EB means the end behavior. Now, I'm going to attach the worksheet, so you'll be able to see it. But the answer will just say it's even, it's odd. Well, if I look at, I've got 2, 1, and 2. So that's going to be an odd end behavior. And it's a positive. There's no negative out in front of it. So we know that just like a cubic, it goes down here and it goes up there. So then what we're going to do is we're going to decide at the zeros what the multiplicities do. So here at this one, this is going to touch, touch because it's an even multiplicity. At -2, it's going to cross, and at -5, it's going to touch. So let's put these things here. So I've got -5, I've got a -2, and I've got a +5. So these are the 3 places that it's going to come from. And we also know that it's going to come from this direction, and it's going to come up to -5. But according to -5, it's going to touch and it's going to go down. Now, we don't know how deep, so this is what we're talking about, a sketch. But now what it's going to talk about is at 2, it's going to cross, so I'm going to go through. Now the question is, where does it hit? Well, it's going to hit at the y-intercept. So again, remember that in order to find the y-intercept, we put 0 in for x and we solve. So what I did is I put all of the values of 0 in for x. So 0 minus 5 is 25. 0 minus 5 is -5 squared, 25. 0 plus 2 is 2. 0 minus 5 is -5 squared is 25. So the y-intercept is going to be all the way up at at positive 1250. So we know this is going to shoot way off the graph, up, and of course I'm not going up that low. But the thing is, so we know it's going to cross at 1250, and then I'm going to come back down, and when it gets to positive 5, I know that it's also going to touch because of that multiplicity. And then it's going to go off to the other side, which does Makes sense with the end behavior. So what I'm expecting you to do now, is this going to be perfect? Is this going to be the right depth? No. But again, we can know some certain things. We can know all of the zeros, which again are x-intercepts. We can know the end behavior. We can know the multiplicity, whether it crosses or whether it touches. So these are the pieces I expect you to know when you're doing your homework and when you're doing your test. So let's look at the next one. This is easy. Again, the zeros here are at 2, the zeros at -4, and the zeros are at 5. So I know that at -4, at 2, and at, oops, that was supposed to be at 2, not -2, 2 and 5. This is where I'm going to, let me erase that little guy. This is where I'm going to have my zeros. Now, if I look at it, we have a degree of 1, degree of 2, degree of 1. So that means all total, my degree of the polynomial is going to be 4, which is even. And there's no negatives in front of it, so that means my end behavior is going to go this direction and this direction. So basically from each of the roots, it's going to go up this direction and up this direction. So now we've got to decide where it's going in between. So at -4, we touch because it is an even multiplicity. So that means it's going to go back up, and then it's going to cross somewhere at the y-intercept. So we got to figure out what that is. So let me calculate that out. So once again, we have a huge y-intercept. So it's going to go, again, way up and cross at 160. So this is not a very to scale sketch. So, but then it's going to come down when I'm going down to 2. And if I look at 2, it says it has an odd multiplicity. Remember, odd multiplicities mean it's going to cross. So it's going to come down somewhere, and then it's going to come back up, and again, continue with that end behavior and cross in this direction, because once again, that multiplicity at 5 is 1. So we knew it was even, we knew the end behavior, and we know what the multiplicities say. So let's look at the next one. So we can look at the zeros. Now I've got an x squared. Well, that means that if there's nothing in the binomial added or subtracted, that means there's a 0 at 0. This means there's a 0 at 4, and this last one means there's a 0 at -2. So now looking at the degree, I've got 2, 1, and 3. So that means it's an even. So 2 plus 1 plus 3 is 6. So that's an even end behavior, but we've got the negative in front. So it's a net even with a negative. I should have just wrote negative here. But what that means is instead of going upwards like a parabola, it got reflected. So everything is going downward. Then we can look at the multiplicity. So at 0, this is an even multiplicity, so that means it's going to touch. These last two multiplicities are odd, so that means it's going to cross. So let's look at these end behaviors. So we got to start. Let me see. We have a 0 at -2. We have a 0 at 0, and I have a 0 at 4. And I know that from the last root and from this root, we're going to go down on our end behaviors. And then once again, I can find my y-intercept. Let's calculate that. So that was really easy. Putting the 0 in for x means I have a y-intercept of 0. So that means it's going to, again, at -2, it's got that odd, so it's going to cross. At 0, oops, it doesn't matter. We're not quite sure what it is, but at 0, I know that it definitely touches. It doesn't go through because, again, at 0, it had that even multiplicity. And then it comes back up and goes down. So what is this actually the sketch of the graph? Well, let me look at it. When I'm looking at the actual Desmos graph, it goes like this, and it went way high on that one. I had no idea. There's other ways to calculate this, but what I'm worried about right now is that you understand where the roots are and whether or not it crosses or whether or not it touches. That's the objective for this one. So I'm going to look at this next one. This is a negative, so I know it's going to be flipped. When I'm looking at my end behaviors, there's 3, there's 1, and 1, so that's going to be an odd. So remember that when a regular odd or a cubic comes down from the bottom left and goes up to the right, but this has the negative in front, so that means we're going to flip it. That means it's going to go this direction and go down this direction, so we don't want that. It's going to be an odd behavior, but it's negative. Odd end behavior, but it's negative. And then my zeros are at -8 with a multiplicity of 3, so we know that's going to cross. And we have a root at 5, and we have a root at -3. So let me write -8, 5, and -3. So we can start again with these end behaviors. The end behaviors say we're going to go up this way, and we're going to go up this way. And the cool thing is it crosses each time, but I can already find out what my y-intercept is going to be, and I can already tell this is going to be super, super, super big. So I'm going to quick calculate it. So if you can see from here that the y-intercept is going to be at 7,860, so it's going to be super huge, so we're not going to bother doing that. But we can see that, again, we're not going to bother graphing that. It's way too darn high, so this is not to scale. But again, seeing that we go down, crossing at -8, we go up, crossing at -3, and then we go all the way up to 7,000. Again, way not what our graph allows, but then crossing again at a +5. So what I'm going to ask you to do now is go to the next one and do the same thing. See if you can't evaluate the end behaviors, and then try to graph and find the roots. So now I found the degree of 6, so it's going to be an even. There's a negative in front of it, so even degreed polynomials usually go up like this and up like that, like a parabola. But because it's negative, that means from the last roots, we're going to go down both ways. And then each of these has an odd degree, so that means it's going to, oh, I have C. Good touch. Goodness gracious, they're cross, every single one of them. I got a little overzealous. So then I've also noticed that it's going to cross at y is equal to 0. So we cross here, we cross here, we cross here, and we cross here. And these are no way, when you actually look at the graph, I'll actually demonstrate it. When you actually look at the graph, they're super, super high. Again, going way up into the hundreds, and I realize that. But what I want you to understand exactly is that the roots are here and that they cross. And further on in your studies, you might be able to evaluate how big they actually get or how tall they actually get. So go ahead and try the next one. So starting here, we have a polynomial of degree 5, again, because I've got 2, 1, and 2. That adds up to 5. And we know that odd degrees start from below and go up like this on like on a cubic. But this negative says we're going to flip. So this means I'm going to go up to the left and down to the right. So let's put our roots at 1, at 5, and at -5. So I know from the first root I'm going to go up this way. From the second root I'm going to go down this way. And that we have, it's going to be touching at 1, it's going to be crossing at 5, and it's going to be touching at -5. So let's do this. So we got here, we're going to touch here, and it's going to touch at 1, and it's going to cross at 5. So here's one of the things that made me pause for a second, because I calculated my y-intercept to be a -125. But even if I, for example, if this graph, and I compared it to the Desmos, even if I did, and I went, it actually goes really super high and crosses up here, and then it comes back down, and then goes down. But I had a y-intercept of -125, and that didn't go down here. Well, what I had to go back down and realize is that I had actually miscalculated the y-intercept, and it should have been positive. So one of the things to do, and I inadvertently did this as a check, is we need to make sure that everything lines up. That not only if it's going to touch here, that means it's going to bounce high. And if it's not going to come again crossing all the way until 5, there's no way my y-intercept could have been negative. So make sure you take a second check on that. And I'll show you the actual Desmos graph of that graph. So it crosses here at 125 and then touches at -5 touches at 1, and then it crosses at 5. So this is a great way to double check yourself to make sure that everything you do lines up. So for the last two, go ahead and try it, and then I will give you the roots, the degree, and the multiplicity. So this is of degree 6. So this means it's an even multiplicity, which means it follows the same pattern as our parabola. So that means it's going to go up from this direction, and it's going to go up from this direction. So the question is, what does it do? Well, because at a multiplicity of 2 at -6, that means it's going to touch here. It's going to go up to some form, but at 3 and -3 and -2, it's going to cross. So this is the way it's going to go. And then we can find out where the y-intercept is by plugging those values in. It's actually going to be a lot higher than what I drew it here. So let's look at this next one here. This has a degree of 3, which means, again, it's going to go off this way and up this way because it's an odd degree. There's no negative in front of it. So we have our root at -4 and +4. It's going to come up from in here, and then it's going to go off in that direction. And then when we're looking at what it's going to do at the zeros, well, at -4, it's got an even multiplicity, so it's going to touch. And then at an odd multiplicity, it's going to cross. So it's going to come down like this, and then some way it's going to go up like that. And if we're wondering where the y-intercept, or where it should have crossed, let's look at that. So it should have gone down to a -64. So this loop here, we could have actually exaggerated a little bit more and gone a lot lower here. So once it touched here, we're going to go all the way down to a -64. And again, not to scale, before it drops up. And forgive my graphics here. Okay. So again, multiplicity, degree of the polynomial, end behavior, and zeros is the objectives of this particular lesson.